The second part of the modern atomic theory deals with what's called quantum numbers. And we're going to go through these quantum numbers, and to be honest, it's very much like riding a bike. I can tell you all day how to what these are and explain each one, and we're going to do that. But bottom line is you need to get on the bike, and you need me to help hold you on that bike, and you need to ride. And once you get comfortable, you'll find out, wow, I'm riding this bike and I can do this. So let's just start marching through this. The quantum numbers are based on the energetics that we've learned with the modern atomic theory, especially with Schrodinger and Heisenberg. So let's start here. This is an introduction, and you can see that with the outline here, quantum numbers, introduction. Number one, every electron in an atom is assigned a quantum number. And what you're going to find out is that every electron actually can be designated with 4 quantum numbers. There are 4. And that's what we're going to focus on. Number 2, quantum numbers indicate different energy states of electrons in an atom. So this whole idea of quantum numbers is about energy. Number 3, based on the Schrodinger model, electrons change energy states based on emission, which is emitting or releasing energy in the form of whole numbers of photons, or absorption, absorbing energy in the form of whole numbers of photons. And that's where we did the emission spectrum lab. The energy is described by E equals hf, where E is energy, h is Planck's constant, which is 10 to the minus 34th joules, it's tiny, and then F is frequency. So frequency and energy are directly proportional. There is an assumption: the electrons in a multi-electron atom, which is every atom except hydrogen, occupy energy states similar to those of the hydrogen atom, which to be honest is not that true. So here's kind of what we saw in the emission spectrum lab. We saw a bright line spectrum, and again, I'm not sure you can see this. There's a nice dark violet line, and then a blue-green aqua line, something like that, and then a red line over here. And this is hydrogen. And this comes from here where electrons existed at this energy level 2, n equals 2, which we'll talk about what that means. And they got zapped with electricity or heat, and they were raised to a higher energy level. This one here, this one to here, this one to here, and this one even beyond what's written there. But that made the atom very unstable, especially the electron. So like anything else, we want stability, especially energetically. So to become stable, these electrons will return back to their ground state. Right now, they're in the excited state. When this electron returns back to the ground state, it gives off energy, and you can see that energy is in the form of red color. Red is a frequency. Here you have the aqua color. See, the red is here. Here's that blue aqua color, okay, where from energy level 4 drops down to energy level 2, because again, it's excited here, it's unstable, wants to go to the ground state. This electron, it corresponds to this violet, and there's actually 2 lines. You can't really see them there, but one of them's violet. It goes from energy level 5 down to 2, returning to the ground state. And then this one also is violet, returns to the ground state. So this shows you the Bohr model, which only really dealt with the hydrogen atom. It works for hydrogen. The more complicated atom doesn't really work, but we still use the idea of the energetics because it helps us. Once again, if we look at the excited state of an atom versus the ground state, atoms begin here when they're neutral, they're in the ground state. This is the nucleus, and there's an electron, it's the hydrogen atom again. And if we hit it with a photon, which is a bundle of light energy, it doesn't have any mass, but it does have a lot of energy, or we can hit it with electricity, notice that that electron goes up into the higher energy level. That's called absorption. It absorbs the energy from the photon or electricity, absorbing it, and goes up to the higher energy level, which in this case is energy level 2. It becomes unstable up there. It wants to return back to the ground state. So it does in the form of emission. It will give off that energy, and that energy is a frequency, which is in the color range. So you would see a color when this returns back. And that's what we've stated here. Electrons absorb heat or electrical energy to reach the excited state. That's where you form what's called an absorption or dark line spectrum. And then electrons return, that's this one. Electrons return to the ground state, which is the most stable energy state of the atom. which forms a bright line color spectrum. Notice that the energy is very discrete or quantized, therefore the word quantum. Quantum literally means step. There is a step of energy, and we've talked about this already. You take one step. There's no in between. This is not going up a ramp where it's a gradual change. It's either one step or the other. There's nothing in between.